Hello everyone, thank you for watching my video today. In this video, we're going to talk about some more exponential modeling and also some exponential graphing. So you're going to need a graphing calculator for the first couple problems today. So if you want to get that out now and pause the video, you're welcome to do that. Otherwise, let's get started. Number one, new medicine is effective at wiping out a particular species of bacteria. On average, it tends to kill 46% of the bacteria population every hour. After starting treatment, what percentage of the bacteria population will remain after 4 hours? So remember, for bacteria, we usually want to use this formula here. Okay, so we don't know our A, that's what we're going to be looking for here. And we don't know our A sub 0 either, but that's okay, we'll figure that out later. What we do know is our R is negative 0.46. and our T is 4. So that's all we really need here. We can go to our calculator and type in negative 0.46 times 4 and go e to that power. And we're going to get this. A equals A sub 0 times 0.15882. Which means that 15.882% of the original bacteria would still be left after 4 hours. Second one, over the course of 9 years, an account steadily increases in value from 15,000 to 21,000. What was the interest rate? So that's our simple interest formula, which is going to be A equals P times 1 plus R to the T. We are currently at 21,617. We started at 15,000. And 1 plus R to the 9. So dividing by 15,000 on both sides. And you get 14.411. Raising both sides to the 1/9 power. We get this. And then subtracting 1, we get our final answer of 0.345, which is 34.507%. Third one, Metopia is a lovely city that everyone wants to live in. There are currently about 200,000 residents, but with the town's popularity, that number is growing by 17% each year. Again, that's our simple growth formula, same one as the last one here. How many people were living there 5 years ago? So we're going to start with, we currently know there are 200,000 people, and we want to know what A was. There's two ways to do this. We could set this 200,000 equal to our principal 1 plus 0.17 to the 5. Or you could put 200,000 here and make this a negative 5 power. Both of these will work just fine. All right, but we have this set up here, so let's go ahead and do this the way we got it written. So 1 plus 0.17 raised to the 5th power. And 200,000 divided by that number. $91,222 people. All right. So now we're going to talk about some things today. I want to show the next slide there. Because I actually want you to pause the video at this point and go to the next slide and just recall from first semester transformations. Write down what each transformation would take place depending on what we are looking at in our expression. Pause the video now, try those, and then come back when done. So here's what you hopefully would have got. The first two are vertical shifts. The next two are horizontal shifts. And then we have some vertical stretches and compressions. And finally, some reflections at the end. Why are we doing that? Because we're going to need to use that in our next piece here, which is graphing exponential functions. So graph each of the following using transformation rules. Identify your intercepts, domain, and range, and also the asymptote as well, the horizontal asymptote for each one. All right. So let's start with graphing 2 to the x. Let's put some numbers in that are easy for us to know. So 0, we'll get 1 back. 1 will get 2 back. 2 will get 4 back. 3 would get 8 back. How about negative 1? Negative 1 we get 1/2 back. So our function should look something like this. The x-intercept, there is none. It'll never cross that line of y equals 0. The y-intercept is at 0, 1. The domain is all real numbers. Our range is 0 to infinity. And our horizontal asymptote is y equals 0. So what's going to happen here? Well, we're going to move right 3 and down 1. So we're going to take all those points and move them right 3 and down 1. So starting with 0, 1, right 3 and down 1. 1, 2, right 3 and down 1. 2, 4, right 3 and down 1. So it would be 5, 3. And then 3, 8, right 3 and down 1. So that would be 6, 7. And then negative 1, 1/2, right 3 down 1 would be right about there. So there's our graph. Now we do have an x-intercept, right? So we do have an x-intercept, which it looks like right about here, about 3, 0. And if you're unsure of that, you could always set this equal to 0 and solve. The y-intercept now, if we put 0 in for x, be 2 to the negative third minus 1. So it'll be 1/8 minus 1, which is negative 7/8. Our domain is still all real numbers. But our range now is negative 1 to infinity because we moved it down 1. So our asymptote is y equals negative 1. Okay, the third one, that is going to reflect it horizontally here. So if we put 0 in, we're still going to get 1 back. But if we put 1 in, we're going to get negative 1, so it'd be 1/2. If we put negative 1 in, we'll get 2 to the positive 1, so that's 2. So basically it's just going to be reflected over the y-axis. So no x-intercept, y-intercept still of 0, 1. Our domain, our range, and our asymptote will all be the same as our original. All right, our next problem is the same thing. Now we're talking about, instead of 2, we're talking about the number e. If you're unsure what the number e is, you could always just type it into your calculator and see what the number e is. It's approximately 2.718. Okay, so if we're going e to the x here, e to the 0 is 1. E to the 1 is 2.718. And e to the negative 1 would be 1/e. So let's see what that is in our calculator. 0.367, so it's about 0.4. So again, our graph should look something like this. No x-intercepts. The y-intercept is 0, 1. Domain is all real numbers. Range is 0 to infinity. And again, our asymptote is y equals 0. So what's going to happen here? 3 things. Horizontal reflection, a vertical compression, and a vertical shift. So if you remember, we can do this the way we did it back first semester. Like that. All right, so 0, 1 is going to go to 0, 1/2 of 1 plus 2, which is 1/2 plus 2, 2.5. So 0, 2.5. And then 1, e is going to go to negative 1, e over 2 plus 2. Let's see what that would be. E over 2 plus 2 is about 3.4. So negative 1, 3.4. And then negative 1 comma 1 over e is going to go to positive 1 comma 1 over 2e plus 2. Which is about 2.18. So it should be right about there. All right, so our graph then is going to look something like this. It should never cross y equals 2 because of that plus 2 there. So again, no x-intercepts. The y-intercept here, when we put 0 in for x, it should be 2.5. So 0 comma 2.5 or 5 halves. Our domain is, again, all real numbers. Our range is 2 to infinity, and our asymptote is y equals 2. All right, so last one here, it's going to move left 3 and then down 2. So we take our 3 points and move them left 3 and down 2. So if our original point was here, here, and about here, we're going to take all 3 of those and move them left 3 and down 2. Our new graph should be right about there. Or you can take the points one at a time and do that as well. All right, so our x-intercept here, we actually do have one. If we set this equal to 0 and solve, we're actually going to have something that we can't do yet without a calculator. Okay, so we can find this via the calculator if you want to do that. So you can go ahead and type this into our calculator of e to the x plus 3 power minus 2. And when you graph it, remember how to find intercepts. We're going second trace 0. And you're going to go left of the 0, right of the 0, and on top of the 0, we get about negative 2.307. Okay, our y-intercept, if we put 0 in for x, we get e to the third minus 2. I'm not going to bother finding what that is in the calculator, just e to the third minus 2. Our domain is, again, all real numbers. Our range would be negative 2 to infinity, and our asymptote is y equals negative 2. Okay, so there's one more slide left. At this point, I'd like to pause this video. Try that slide on your own. When you're done, you can come back and check your answers, and then you can also check your answers on Schoology. Pause the video now and try the last slide. All right, here are the answers to the last 4 problems. Well, it's really one problem, just 4 different transformations on the graph of 3 to the x. And with that, that'll end our video for today. Thank you, as always, for tuning in, and we'll see you again soon.